Hi everyone, welcome back to the Code2Conquer series, your step-by-step guide to mastering DSA for placements. This campaign is brought to you by the Google developer groups at VIT-AP. Now we've completed two problems of day 17 and now we are moving to the third one. This is the continuation of the first problem of day 17, reversing a singly linked list. So it's a similar question, but we should be reversing the linked list in groups of the given size. So let me explain. We'll be given with the head of a linked list and we'll be given an integer. Let's call it k for now. So we should be reversing groups of k in the linked list. So let's look at some test cases to get some clarity. Suppose we are given with the linked list 10, 20, 30, 40, 50 and 60 and we are given k equals to 2. So we should be reversing groups of 2 in the linked list. So we should be reversing 10 and 20 to form 20 and 10, 30, 40 to form 40 and 30, 50, 60 to form 60 and 50. Now you might be thinking, what if there is not enough nodes for reversing? So let's look at this example or input. So we are given it the same input 10, 20, 30, 40, 50 and 60 and we are given k equals 4. So what should we do? We will take the first group. We can have 4 elements, right? So we'll take the first group, we will reverse it 40, 30, 20 and 10. Now we do not have enough elements to form the group. We only have 2. So we should just keep them as it is without reversing them. Even if we have one element, in this case we have 2, even if we have 3, just keep them as it is and do not make any changes. Only make changes if you have 4. So I hope you got what the question is and what the problem statement is. So now let's go to the coding part. So this is the question, and will as I told you, will be given with head, will be given with k. So we will be given with this function. We should fill this and return the head of the linked list after reversing it in groups of k. So let me explain this. It is a hard question, so it would be great if you understand this. Let me explain. So you suppose think that you are given with this linked list and you are given k equals 2. So we should be reversing groups of 2. So you should be taking this group, reversing it, and this will become like this 2 comma 1, right? Am I right? Yes. So next you should be taking this group 3 comma 4 and you'll be having 4 and 3. Now you have only one element and you do not have enough elements to form a group. So you keep it as it is and this will be our final answer. So it's 2, 1, 4, 3 and 5. This will be your final answer. Now let's see how we can do this. So uh, let me explain. So this is our linked list, initial linked list. So what should we do? First thing, we have to find the kth node. Always we have to find the kth node. We should have a function for finding the kth node. See, over here we have our function which will be will make a point towards the kth node in our linked list. So what does that do? So in our case k equals 2, right? So if you send head in this function, if you send head, head instead of temp in this function and you'll send k equals 2, then our pointer will be pointing towards the second node because k equals 2. That means we should be moving 2 nodes further. I mean, this is the first node and this is the second node. So we want the node after the ending node of our group. So this is the ending node of our group, right? So we'll be having this as our kth node. So kth node pointer will be pointing towards this because our k over here is 2. So this will be 1 and this will be second node. So our kth node will be pointing towards 2. Now also make sure that you have a temp pointer initially pointing towards head. See, we also have a temp pointer pointing towards head over here. So make sure that you take care of this. So our temp is pointing towards the head, our kth node is pointing towards the kth node. Now what should we do? If we see in our final answer, the first group is reversed, so we should be reversing this group. Am I right? We should be reversing this group. But if you solve the first problem of day 17, which is today, you might be knowing that if we have a linked list like this, if we send the head, we can reverse this linked list if we send the head in the function, which only happens when the last node is pointing to null, right? You cannot send a part of a linked list and you cannot send the head and expect a part of the linked list to be reversed. So you have to make sure that this points to null for reversing this 1 and 2, so that you will have 2 and 1. So what can we do? So what should we do? Just make the kth nodes next point to null. Simple. So you'll be having 1, 2 pointing towards null, 3, 4, 5 which is also pointing towards null. So we have our linked list. This is our head. This will be our tail. This will be our temp, and this will be our kth node. Right now, you can. I'm not going to tell how we'll be forming a reverse function, because we covered it in the problem 1. So we'll be having a reverse function to which we'll be sending our head, and it will be reversing this part because this points to null, and it can only reverse the first 2 nodes. So after sending our head to the reverse node, we'll be having our linked list to be reverse. So it will be like this: 2 points to 1 and 1 points to null, but the pointers stay at their place. They do not get exchanged or interchanged. So kth node will be over here only, temp will be over here only, and head will be over here only. Now we, in the final output, what do you think is our head? 2 is our head, but here our head is pointing towards 1. So what can we do? We should make sure that head will become kth node. But we should not do this for all the groups. We should only do this when temp and head both are at one place. So after reversing a linked list, if both temp and head are at the same place, we should be moving the head from the temp to the kth node. So if we perform this condition, if and only if head equals temp, we have to perform this step. So head goes from here to here. So I hope you understood how we got a new head. So we'll be having our linked list like this: 2, 1, head, kth node, and our temp is over here, and this is pointing to null. Now, and we also have our 3, 4, 5, which is also pointing to null. Now we have to move our temp to 3, find the kth node, which how we initially did, and we should be making this null and reversing this group also. But how do you think we can send a temp from here to here? We do not have any link between 1 and 3. We do not know the address of 3 for sending temp from here to here. So what can we do? Over here we removed the link between 2 and 3 and made 2's next point to null. So before removing the next of 2 from 3 to null, make sure that you store 3's address. Make sure that you stored 3 as next node. How can we store this? Next node equal to kth node dot next. So that we'll be having our address of 3, so that 1 can point to 3 whenever we want we want to join the groups. So make sure that your next node will be pointing towards 3. So now we have our next node pointing towards 3. This is our next node, right? So I hope I'm going slowly and I hope you are understanding. So our temp is over here. So make sure that your temp reaches next node. So our temp will come to 3. Got it? Our temp is not over here anymore. It's over here, right? So after the temp comes to 3, just do the steps which we did above. So make sure that you send this temp to the find kth nodes find kth node function. So we'll be having our kth node over 4. This will be our kth node, right? This is the first element, this is the second element. We want groups of 2, so that will be our kth node. Now, as I told previously, we should be storing kth nodes next as the next node. So store 5 as the next node. This is not our next node anymore. So 3, 4, 5. This is our next node. This is our kth node and this is our temp. So what should we do after this? After creating a next node, after pointing next node, just remove this and make sure that you point the force next to null. So the force next should be pointing to null, so that we can send 3 to the reverse and reverse function, and it reverses our linked list. So after sending 3 to the reverse linked list, this will be our linked list. So 4 is pointing to 3, 3 is pointing to x. So we are sending reverse of temp. So this will reverse this linked list and we'll have this group, right? Now, and there is another group 5. Next node is over here. This is pointing to null. And there is another group 2, 1. And this is our head. And this is pointing to null. Now, we have to connect this. We have to, okay, let me do one thing. We have to connect this to this and this to this. How can we do this? There's a simple logic. So what can we do? So let me tell. Before your temp goes to the next node, see, let me explain. Initially a temp was over here, right? We moved it from here to here, right? Temp is brought from here to here, right? Before your temp goes to the next node, make sure that you also store where this temp was there previously. So take another pointer and place it at the temp which was there previously, so that after reversing the nodes after it, we can point the temps, we can point the previous. So this was previous, right? Now this is our kth node, right? Because we did not change this, and our temp is over here. And as I told you to store the previous, before sending the temp from 1 to 3, make sure that you store the address of 1 as previous. So we'll be having our previous at 1, and our 4 is the kth, 3 is the temp, 5 is the next node. So make sure that your previous points to the kth node. I hope you are understanding this. And similarly, this will be done. This step is done. So where is our temp right now? It's over here. So what should you do? You should make sure that this will have our previous and move the temp from here to the next node, right? So this is our temp. This is our next node. Temp is brought from 3 to 5, right? Because we have address of next node, we'll be moving our temp from 3 to 5, and 5 is pointing to null. So if we send this If you send 5 to the find kth node function, we will receive kth node equals null. Because we do not have two elements to form a group, so we'll have our kth node equals null. So what do we do if we receive kth node equals null? As I previously told, we will be breaking out of the while loop, because we do not want to execute any of the steps after that. So if kth node is null, we just have to complete our execution. Before breaking this, now this link is made. We should also link 3 to 5, right? 3 to 5 should also be linked, right? Before breaking, make sure that your previous is made equal to the is made equal to the temp. So what happens? Your 3 over here, your 3 which was initially pointing to null now will be pointing to temp k, I mean 5, right? So what is this? 2, 1, 4, 3, 5. This is exactly what we wanted, and this is our final answer. We'll be returning our head, and our linked list over here is done. So let me summarize everything once again. So we'll be given with our head and we'll be given with the integer k. First thing, make sure that you point temp at the head, and just create this pointer for now. Let's look at it afterwards. So just run while the temp not equals null, just keep executing. So as I told, you have to always find the kth node using this kth node function. We should be having this function as well. We should be creating it as well. Let me show you afterwards. So it's simple. It's simple, right? So I'll not be going too deep. You'll get confused. So find the kth node and make kth node is pointing to it using this function. Next, if kth node equals null, that means if we are at the end and there are not enough nodes to create a group, just break. But what does this if condition do? As I told, we should be pointing at 3. Where is it? We should be pointing at 3 to 5, right? So this is exactly what this if condition does. So make sure that your previous dot next is equal to the temp. So initially in this case our previous was at 3 and the temp is at 5. We should be making sure that our previous will be pointing to the temp. So I hope you understood why this if condition is used. So you might ask me, we can execute this step. Why do we need this if condition? We should be executing this step, yes. But why do we need this if condition? Assume this is your linked list and you are given k equals 3, right? So initially your previous last will be null. If your k equals 3, your kth node will be reaching null. Should you think this steps to be should be executed? Because previous last was initially null. And does null dot next have any meaning? No. So this step should not be executed in certain cases. It should not be executed when our previous last is previous last equals null. So I hope you got why we are using this if condition. And going further, so I hope this if k equals null, check that our previous last is not null. If it is not null, execute this step. If it is null, just break out. Just break out from our for loop, because see, this will be pointing to null. And if k equals 3, what should be our answer? Our answer should be this itself, right? So there's no point of performing anything. Our head will be over here. Initially also our head was here. Return head and we have our final answer. There's no need to perform any of the steps we discussed previously. So clear till here. Now, as I told you before moving your 2 from 3 to null, make sure that you store this at the next node. So this step is responsible for storing the next node before making our kth node to null. So kth nodes next should be pointing to null. Now we should be sending temp to reverse a linked list. So our linked list will be reversed till the kth node. Now, as I told you, for the first group, if temp equals head, make sure that your head should be going to the kth node, right? Over here, a temp and kth node are equal. Temp and head are equal, right? So after reversing, your head should be moved from here to here. So this head should be moved only for the first group, and for the first group, head always equals to temp. So if temp equals head, just make sure that your head moves to kth node, which will be our first node of our answer. So make sure that this if condition is done as well. So why is this else? This should be executed because previous dot next goes to the kth node, which is this step. Let me show you. Which is this step. Previous dot next should be gone to the kth node. Now, why do you think this is in the if condition? So why is this in the else condition? This is in the else condition because this condition is for the first group. First group. If it's not the first group, this condition will be executed. Because let me explain. If it's the first group, do you think this condition should be executed? No. Because initially, if it's the first group, our previous last will be null. Right? Null dot next does not have any meaning. So this should not be executed for the first group. So if it's first group, this will be executed. Why is this the first group? Temp equals head. So if temp equals head, what does it mean? It's the first group. So if it's the first group, this condition should be executed. If it's not, then this should be executed. So I hope why is this in else and why is this in if and why is this in else if else, not else if else. Now let's look at these two steps. As I previously told, we have to make our previous last pointer point to the temporary temp node, and temp should be moved to the next node. So that this should be done because we can point our previous last to the kth node over, which is over here. So this step is done for this, and temp should be moved to the next node, and finally we should return the head. So if you are confused, let me summarize this entire thing once for you. uh, so first things first, you should be creating your temp, which will be pointing towards the head. Next, you should also create a previous slash which will be pointing to null. Now run this while loop. Run this while temp does not equals null. So using this function, find the kth node from the temp. Always find the kth node from the temp. After finding the kth node, if the kth node equals null, what does it mean? There are no enough nodes to create a group. Just the primary thing is breaking out, but you also have to make sure this happens, right? Previous nodes next should be pointing towards the temp, so that we will have a link between the second last group and the last group. And this next node should be noted. It should be conserved, it should be preserved, so that we can move our temp from its place to the next node. And kth nodes next should be made to null, so that we can send it to reverse, and reverse function will be done. And if temp equals head, it means that it's the first group. Make sure that your head will be renamed to the kth node. I mean, the kth node will be renamed as head, because it's the first node after in the final answer. Else, if it's not the first group, make sure that this happens. Previous last should be pointing to the kth node. Then finally, previous last should be going to the temp, and temp should be going to the next node. Finally, return the head. So now let's come to the code. Coming to the code, as I explained, this is exactly what I explained, right? Now coming to this function, for finding the kth node, from the temp, always from the temp, finding the kth node. See, k, make k equal to k minus 1, just for making it simpler for us, so that we can write this k is greater than or equal to 0. So we have to run this while loop where temp moves from temp to temp dot next, and k is decremented. So make sure that you do this, and k should be decremented. Temp will be going to the kth node from the initial this temp given. So we'll be returning a kth node from the temp. We'll not be doing anything to the temp. This is just the name. If you want, let's make it x, right? X, 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 and return x. So this is nothing but just the name. So we should be returning this, or the kth node from the temp, kth node from the given x. So we should also have a reverse method, which will be the same as the reverse in the first problem which we solved today. So we'll be having a previous, we'll be having a front, we will be storing our front, then we'll make our temp next to previous will be brought to temp, and temp will be brought to front. This is nothing new, this is the first problem which we solved today. So yes, so we'll be having this function and this function, right? So yeah, this is the entire code, and if you got this, it's great that you got this. It's slightly a trickier question than the first two problems which we solved today. And now let's come to the time complexity. What do you think would be the time complexity? Time complexity will be big of 2n. Let me explain why. See this. We'll be calling this function and this function. This will make sure that the kth node will be moving. See, what is this? We are traversing through the linked list, right? So it will be moving k times, then the next k times, then the next k times, till the k reaches null, kth node reaches null. So what does this mean? We are traversing through the entire linked list once. Similarly, in the reverse, as you know, we'll be having our time complexity as big of n. So we'll be sending a temp initially till the kth node, the entire linked list will be reversed. Then we'll be sending another temp, and till the second group ends, the entire linked list will be reversed. So in this way, we'll be traversing through the entire linked list once more. So this contributes to big of n time complexity, this while loop, and this while loop contributes to a big of n time complexity. So totally the time complexity will be big of 2n, which can be said as big of n. Now coming to the space complexity. As you can see, we are not using any extra space. We're only using the pointers, which will be having constant space complexity. So the space complexity will be big of 1. So yes, I hope you got it. So this brings us to the end of day 17. I hope you got the problem on reversing singly linked list, problem 2 reversing doubly linked list, and this is a great problem to understand how linked list works. This problem, I hope you got this problem. Well, see you tomorrow with a few other questions. Thank you.